Here in the question, it says that consider the following nuclear fission reaction, and below that a fission reaction is given. Further, in the question it is written that in this fission reaction, kinetic energy of alpha particle emitted is 4.44 MeV. Find the energy emitted as gamma radiation in keV in this reaction, and then three different option is given to us. Now we can see that in the question alpha particle kinetic energy of alpha particle is given as 4.44 MeV, and we have to find out the gamma radiation kinetic energy, and the fission reaction is also given in the question. So let's see how we will find the gamma radiation kinetic energy. We can see that here delta m is equals to 0.005 AMU. Now, as we know from the kinetic equations that Ka upon Krn, which is equals to mRn upon m alpha, we have to find out the Krn. So what we will do, and beside this Krn, every value is given in the question. So we will put that and we will find that Krn. So it is 0.08 MeV. Now to find the energy of gamma photon, it is written that 4.65 minus 4.4 plus 0.08. That means 4.4 is a alpha particle, kinetic energy of alpha particle, and 0.08 is Krn. So summation of that minus 4.655, we will get the kinetic energy of gamma radiation, and that is 0.135 MeV.